Hey guys, welcome to our next video lesson here on equations, our single variable linear equations with fractions. I know, I just said one of the forbidden math F words there. I know no one likes fractions and no one likes working with fractions, but here's the deal. After this video is done, I think we're going to present to you a way to approach solving equations that have fractions so that you're going to realize they're not that bad and be confident that you can solve those types of equations. So let's dive right in here. When we've got an equation with a very simple setup with our fractions, where the fraction is just the coefficient of x, we can essentially solve this as a one-step equation using our multiplicative inverse. So we can see that 2/3 is our coefficient, and we have the multiplicative inverse of 3 over 2. Well, when I multiply 3 over 2 by 2 over 3, those fractions are going to cancel to 1. They're going to cancel each other out. And whatever I do to one side, I do to the other side. So we get x equals 39 there, right? Now, what happens though with our equation is not so simple, where there's not just one fraction, which is a coefficient, huh? Okay, so let's take a look here. We've got 2/3 x minus 8 equals 2/5 x plus 7/15. Not only do we have two different coefficients that are fractions, but we have a constant that's a fraction. So we can't just multiply a reciprocal on both sides and get rid of those fractions. It won't work. What we have to focus on, guys, is the fact that what makes these coefficients and constant fractions is the denominator. If we could get rid of those denominators, if we could blow those up, if we could cancel those out, we would not have any more fractions. So that brings us to kind of our fun analogy that we're going to share about how we get rid of these fractions, and that is using the least common multiple cannon. If we're going to blow something up, we got to bring out some heavy artillery to do the job, and that's going to be our least common multiple cannon. Well, as the name implies, the least common multiple cannon uses the least common multiple of the denominators, and that's what we're going to focus on, again, because that's what we're trying to get rid of. So when you look at the numbers, the denominators 3, 5, and 15, we need to figure out what the least common multiple of those three numbers are. In other words, what is the smallest number that all three of them will go into evenly? Well, that is 15. 3 goes in 5 times, 5 goes in 3 times, 15 goes in once. Well, once we have the least common multiple, we treat that as if it's our cannonball, right? And what do you do with a cannonball? Once you've put it into the cannon, you fire the cannon. All right, you ready for this? Ready? Right, that was awesome. You see that cannon go? Let's do it again. Right. Okay, love the sound effects. So we fire the 15 into our equation. And what that means is what we're actually doing when we say fire the 15 is we're multiplying that least common multiple of 15 by each term. The 2/3 x, the minus 8, the 2/5 x, and the 7/15. And when that happens, notice what we end up with. No fractions. 15 times 2/3 is 10. 15 times 2/5 is 6. And then 15 times 7/15 is 7. We have now eliminated all of the fractions in our equation by canceling those denominators using the least common multiple of 15. And now I think we have an equation that we're pretty comfortable solving. Right? One very important factor about the least common multiple cannon is that when we fire it, when we multiply, we have to multiply by every term, not just the terms that are fractions. You can see there I did multiply the 15 times that -8 and got a constant of -120 down there. All right, we've got to do that because all the least common multiple cannon really is our multiplicative property of equality. So if I multiply even just one term on one side of an equation by a number, by 15, I've got to multiply everything in that equation by 15 so that equation stays balanced. That's what our multiplicative property of equality says. Now you can see down there at the bottom, there is a safe haven or a bomb shelter, if you will, where numbers are safe from the least common multiple cannon. And that is if they're inside parentheses. And we'll take a look at that in just a second in an example. But hopefully this makes sense so far. So let's take this now and let's practice on a couple of equations. So we can see the first equation. We have denominators of 5 and 4. So we need to blow those up. We need to get rid of them. So what is going to be our least common multiple of 4 and 5? And that number is going to be 20. So once we have our least common multiple, then we multiply that by each term in the equation. There's 3 terms there, 2 on the left, 1 on the right. So I'm going to multiply it 3 times, and voila, there we go. We now have an equation which has the same exact solutions as the original equation, but has no fractions involved to solve for those solutions, right? So then we're going to subtract 120 from each side, divide by 15, and we are okay with you giving us your answer as either a improper fraction or as a repeating decimal there. As long as the decimal is repeating or terminating, you can give us an exact answer, so that's okay. Let's look at number 2. So same deal. We have denominators there, 3 and 4. Least common multiple is going to be 12. But notice we have numbers now that are inside terms that are inside parentheses. When we multiply that 12 using our multiplicative property of equality, we hit the 1/3, we hit the 1/4, and we hit the 6. But we do not hit the terms inside the 2x minus 1. The reason we don't hit those is because you can see in the next step, we're going to distribute that 4. Well, where did that 4 come from? That 4 came from the 1/3 being multiplied by 12. So that least common multiple of 12 is actually inside that 4. And so when I distribute the 4, it's really like hitting the 2x minus 1 with the 12. All right. And if none of that makes sense, what I just explained, please just remember, do not multiply terms that are inside those parentheses by the least common multiple. All right, you can see we distribute the 4. We're going to combine our like terms, those constants, the -4 and the 3, add 1, divide by 8. And again, you can go improper fraction, or because this decimal terminates, right, it's a rational number, you can give it to us as a decimal. So if these equations made sense, wonderful. If you have questions about the equations that we're working with here, then and the steps we've shown you, please write them down and come to class and ask. But right now, we are going to move on to these 4 equations that we're going to ask you to solve on your own. So what we want you to do is take these equations and solve them and then come back and check your answer. Please don't cheat and just write down the answers. Please try them on your own. Have the work shown to us so that you can get a worksheet when you come to class. All right? Ready? Pause. All right, let's see how you did. So check those solutions there in blue, and let's see how you did. And if you got these, wonderful. If you didn't, please make note of that and come to class and ask questions. All right, we want you to be successful, but we can't help you figure things out if you're not coming in and asking questions. If you do ask questions, all of your endings will be happy ones. All right, and we will see you in class tomorrow.